Now let's see the remaining instructions. So how do you know that the instruction is add? By looking at the D1. So if the output of the decoder is D1 and if the sequence if the timing signal is running is T4, then I can know that I have reached the execution phase of the add. Now in order to execute the add, first we have to get the operand from the memory. So one of the operand we assume that is already present in the AC, and the other one we have to load from memory. Therefore from memory, effective address is present in AR. I am going to load it into data register, same as the earlier operation. And in the next clock cycle, if it is D1 has to be always present. These two conditions have to be checked, D1 and T5, right? Then only I will be sure that yes, the operation is add and already the operand is loaded in DR. Then I'll pass on whatever is present in DR and whatever is present in accumulator to the adder logic, and I enable the adder, and the result will automatically be stored in AC because it is wired, internally wired in such a way that every operation result will go on to AC, right? And along with that, since it is adder, we have to even deal with the carry. So for storing the carry, we are using a bit called E, extra bit, right? So into that extra bit we are going to write C out. So with this our responsibility is over, which means the instruction execution is over. So how many clocks did add take? So whatever the type of add it is, either direct or indirect addressing, it is going to take 6 clock cycles, right? So this one has taken 6 and this one has taken 6 clock cycles, right? And once it is over, if you have to start the next instruction, you have to start from fetching. So if you have to go to fetching, you have to reset the sequence counter so that the timing signal generated will be from 0. Got it? So again from 0 your timing signal will start. Then we can go to the next instruction. See, the next instruction need not be LDA, right? It will depend on how you wrote the program. So the instructions, this is different, and I am talking about the program. So from program we are going to load the instructions one by one. At some point the instruction happened to be add, and then we have just discussed what we are going to do for add. And after that add, some other instruction will be present, right? So how do you fetch it? If you make T0 as 0, automatically by using the program counter everything will be done. The next one will be fetched and executed. Got it? And this is about add. So once the add is over, this is about add, right? Once the add is over, next one is LDA. LDA means load accumulator, which means we are going to load the accumulator with a word which is present in the memory. Now where is that word present in the memory? That will be given by the effective address which is present in the instruction itself, which means in LDA along with that, see this. So the first bit is going to say the mode, and next one is going to say that it is LDA, and here we are going to get the address. If it is indirect address, you have to compute the effective address. Otherwise, this particular one is the address of the word, right? So whatever it is, by the time we reach T4, our AR is going to contain the effective address where that particular operand is present. Now we have to take that word and load into the accumulator, right? So how do you identify that it is LDA? LDA is going to be identified by D2. If it is D2, the output of the decoder is D2 and the timing signal is giving us T4, then I can identify that, oh, this particular instruction is LDA. Now there is one problem here. If you observe the diagram, there is ALU, adder and logic unit. So in our case, actually ALU means arithmetic and logic unit, but in our case we are using just adder and logic unit, right? It is connected to accumulator, and accumulator is connected to the bus, isn't it? And to the ALU there is data register. So data register is connected to ALU as well as accumulator is connected to the ALU, right? And one more register which is connected to ALU is input register. Got it? So bus is not directly connected to ALU. If you have to load something into accumulator, you have to load that. Let us say here it is memory. if you have to load something into accumulator, you have to pass that word into the bus. Now the bus has to pass the word into data register, and now from data register you have to pass it to the accumulator through ALU. Got it? Therefore ALU has to be involved in this transfer. So we cannot load anything into accumulator directly without loading it to data register first, because the only access we have to accumulator is through data register. So first load the required word in the data register, and then through ALU we can load it into accumulator. But then if you want to write something onto the memory from accumulator, it is directly connected, right? You can directly store that, send that word into this particular bus, and bus will send it to the memory, right? So all the other things are connected to bus directly, but AC is not directly connected to the bus. Okay, now see this one. So what is the reason for this? Because we don't want anyone to load it directly or use it for their purpose. The only reason why we are using AC is to store the output of the ALU, right? We don't want anyone to load it unnecessarily. Okay, now see this D to T4. So if it is load instruction which is given by D2, and if the timing is T4, then I know that I have to execute this load accumulator instruction, right? So what are the various things that you should do? I should go to the memory, and into the memory given by the address AR, which contains the effective address, I have to load that particular word into data register first. Got it? And now when will this happen? The word will be available in the data register only at the end of T4, because at the end of T4 we are going to have a positive edge, and since every register is edge triggered, positive edge triggered, the load input will be activated or will be considered only during that phase. Therefore until T4 is over, we are not going to have the word here. Therefore we have to go to the next timing signal, and then only we have to transfer whatever is present in data register into accumulator. Got it? So you might try to write these two in the same clock, like same timing signal T4, but what happens is DR will be loaded with the required word only at the end of T4, right? Then that is why, in case if this DR is going to be loaded with this memory word at the beginning of T4, then at the ending of T4 you can execute it, and both of them can be written in the same place, right, in the same clock. But then we need two clocks here. Now by this time our execution is over. So I told you that whenever the instruction execution is over, we have to make SC0. SC means sequence counter. Sequence counter has to be 0 because LDA is over. Therefore we have to start the next instruction. Got it? So how many clock signals it took? It has taken 6 clock signals, T0 to T5, which means 6 clock signals it has taken, right? And the next one is store accumulator, which means whatever is present in accumulator, I want to store it into the memory at the address given by the effective address, which is present in this instruction, as instruction, which is derived from the instruction. So the next one is store into memory whatever is present in accumulator. So how can I identify that it is stored? If it is D3, and how can I know that I have to execute it? If the timing signal is T4. If this is the case, then whatever is present in the accumulator, I have to transfer it into the memory which is present at the address AR. So can this be done in one cycle? I told you that we are assuming that the read and write cycle of the memory is going to be, or is less than or equal to the timing signal, or is less than or equal to 1 clock cycle. Under that assumption I will be able to write this. So what should be done? See, what should be done in order to execute this? On the bus you have to select the output of AC, right? So how can I select it? To the multiplexers here for the bus, if I give the accumulator number, that S0, S2, S1, if I give it that number, then automatically the outputs will be present on the bus. And then at the same time, if I enable the write, already address register is connected to this, right? At the same time, if I enable the write, it will automatically write it. So with this we have stored the required word into the memory, right? So execution is over. Now what should I do? Since execution of this instruction is completely over, I have to start the next fetch phase. That is why SC should be 0. Got it? Now you have to understand one thing here. The number of clock cycles required here is only 5, T0 to T4, because without going to T5 we have finished the execution here, and now we are starting T0 again, which means the total number of clock cycles which are taken is just 5. So if you observe it, that is the reason each instruction will take different number of clocks depending on what type of instruction it is. Got it? Some instructions might be fast, some instructions might be slow, depending on what are the operations that we have to perform here, right? Okay. Because why are we focusing on this so much is, we have some questions where they will say that add is going to take these many clocks, multiplication is going to take these many clocks. Then you might feel that why should every instruction be taking these different number of clock cycles? If all the instructions are just of 2 words or same size, then why should they be taking so many? Because internally this is the working, so we need different clocks. Next one is BUN, unconditional branch. So how are we going to unconditional branches? How generally branch will be executed is, we are going to keep track of the next instruction that has to be executed by using the in this register program counter. Program counter will always contain the address of the next instruction to be executed. Now if you want to break this sequence, and from the present execution, if you are here, if you want to go to some other point and start the execution, of course you have to modify the program counter, isn't it? So depending on what the program counter contains, you are going to go there and execute it. Okay. Now branch unconditional instruction is going to come with one operand. That operand can be 2 types. One is the direct address to which we have to branch, or the indirect address to which we have to branch. In case if indirect address is given, then we have to get the effective address by going to the memory at that indirect address. Anyway, by the time we reach T4, we are assuming that whatever is present in AR is the address to which we have to branch. Got it? Now if you are at T4 and if the instruction is branch unconditional D4, it means that we have to do unconditional branch execution. And where should we go, where should we branch? That particular address is already present in AR. In this case, AR is not actually the address at which operand is present. AR itself is the operand here, which means AR itself is the address to which we want to branch. Therefore we need not go to memory and access it. So if this is the case, what we are trying to do is, our program counter should be loaded with the address register. This is 12 bits and this is 12 bits. So done. Now with this statement, what happens is, let us assume that you are running a program, okay, and branch unconditional is 100. Now from here you want to branch to 200. If you don't have this statement, the next statement which will be executed will be 101. That is why program counter, if you see the register program counter, initially it contains 100 when you are executing this function, this program, this particular instruction. When you fetch this instruction, during that fetch phase, this will be incremented to 101, which means the next one which will be fetched is 101. But now because of this unconditional branch, now if it is direct address which is provided, then this particular program counter is loaded with what is present in AR. 200 is already present in AR. When during the T3 or T2 phase, 200 is already present in AR, depending on whether it is direct or indirect address. Therefore we are going to write 200 here, right, into the program counter, and so the next address which will be fetched will be from 200. Next instruction will be fetched from 200. That is how we are going to branch. Got it? So at this point, at T4 itself, the execution is over, and once the execution is over, we are supposed to fetch the next one. In order to enable that, make SC as 0. Got it? So how many clocks did this branch unconditional take? So T0 to T5, T4, which means 5 clocks. Again, this is also 5 clocks. See the difference, 6 clocks and then only 5 clocks here. we'll even see the instructions which will take even lesser time. Okay, and the next one is branch and save address and ISZ. Okay, I'll erase this and I'll start these instructions. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into university is better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.